Are you preparing for a software engineering interview or looking to master advanced microservice design patterns? In this video, we dive deep into the CQRS, Command Query Responsibility Segregation, pattern, a powerful architectural approach for optimizing performance, scalability, and maintainability in complex systems. Key concepts: command, operations that change the state, examples: create, update, delete. They are usually processed asynchronously. Query, operations that retrieve data without modifying it, example: read. They are typically processed synchronously. Event sourcing, optional, stores every change as an event, enabling reconstruction of the current state by replaying events. How it works: write model handles commands and updates the data store. Read model handles queries and retrieves data, often from a read-optimized data store or cache. Event bus transfers events from the write model to the read model, ensuring eventual consistency. Advantages: scalability. Separate models optimize reads and writes, enabling independent scaling. Performance. Specialized read stores improve query performance. Security. Different models allow fine-grained access control. Challenges: complexity. More components and data synchronization increase complexity. Eventual consistency. Queries may not reflect the latest state immediately. Maintenance. Requires maintaining multiple data stores and sync mechanisms. Example use cases: e-commerce systems, high read operations, browsing, and complex write operations, order placement. Social media platforms. Separate feeds, read, from post-creation, write. What is CQRS and why is it used? CQRS, Command Query Responsibility Segregation, is a design pattern that separates read and write operations into distinct models. The command model handles actions that change state, examples: create, update, delete, while the query model handles data retrieval without modifying state. Why it's used: to optimize performance and scalability by separately tuning read and write operations. To enhance security by segregating access control for commands and queries. To facilitate complex business logic and data consistency requirements. What is the difference between CQRS and traditional CRUD operations? In traditional CRUD, the same model handles both read and write operations, which can lead to performance bottlenecks and complex data consistency logic. In CQRS, commands, CUD, change state but do not return data. Queries are retrieve data but do not modify state. This separation allows for independent scaling and optimization of read and write operations. How to design a CQRS-based microservice for an e-commerce order system. Command model handles commands like create order, update order, and cancel order. Uses a write-optimized database, e.g. event store, MongoDB, for transactional consistency. Query model handles queries like get order details and list orders. Uses a read-optimized database, e.g. Elasticsearch, Redis, for fast retrieval. Event bus propagates events from command model to query model for data synchronization. Ensures eventual consistency between models. Example flow: create order command write model event, order created. Event bus read model update. How to handle eventual consistency in CQRS. Eventual consistency means the read model may not immediately reflect the latest state after a write operation. Strategies to handle it: use event sourcing to replay events and reconstruct state. Implement versioning to handle conflicts. Use read repair techniques to update outdated read models. Display appropriate UI messages like updating to manage user expectations. How to implement CQRS with event sourcing. Event sourcing basics. Store every state change as an event, e.g. order placed, order shipped. The current state is reconstructed by replaying events. Implementation steps. Use an event store, e.g. event store DB, Kafka, to persist events. Command model saves events instead of updating state directly. Event handlers consume events and update the read model. Example workflow: place order command event, order placed, store event update read model. Frameworks: Java, Axon, Eventuate, .NET, Mediator, Eventflow, Node.js, Nest.js CQRS module. What are the challenges of maintaining multiple data models? Data synchronization, ensuring consistency between write and read models. Complexity, managing multiple databases and event handlers. Eventual consistency, handling scenarios where the read model lags behind. Transaction management, coordinating transactions across distributed systems. Operational overhead, increased monitoring and debugging complexity. When to use CQRS versus CRUD. Use CQRS when there are complex business rules for commands. High read-to-write ratio, e.g., e-commerce, social media. Scalability and performance are crucial, e.g., high traffic systems. Different security requirements for read and write operations. Use CRUD when the application is simple with basic create, read, update, delete operations. No complex validation or business rules. Consistency and simplicity are more important than scalability. How would you scale a CQRS system for high-traffic applications? Read model scaling. Use caching mechanisms, e.g., Redis, CDN, and read replicas for high concurrency. Write model scaling. Use distributed event stores, e.g., Kafka, Event Store DB, for horizontal scalability. Event bus scaling. Use message brokers, e.g., RabbitMQ, Kafka, to handle high event throughput. Microservices architecture. Deploy read and write models as independent microservices for isolated scaling. Database sharding and partitioning. Optimize data storage for both read and write databases. Example tools: Kubernetes for container orchestration, Elasticsearch for fast queries, and CQRS frameworks like Axon or Mediator. Study tips: understand the theory, master the core concepts of CQRS and event sourcing. Practice with examples. Implement CQRS patterns using frameworks like Axon, Java, or Mediator.NET. Real-world scenarios. Study case studies of systems using CQRS, e.g., e-commerce, banking. Don't forget to like, subscribe, and hit the notification bell for more videos on mastering Git, microservices, and software architecture.